Welcome to Chapter 7.4 Algebraic Identities and Trigonometric Substitutions of the BC Multivariable Calculus class. This is Mr. Seamon's G period, and I'm happy to help you guys with Chapter 7.4's question number 21. Right here we have the integral of 1 over x squared plus 4x plus 5 dx, and the exercise problem says that we should use substitution to find the integral. First, I'll start with writing what the derivative of dx is, because considering how we have to use substitution, we have to be able to substitute tan t minus 2 in for x, and so that means we have to have a dt further on, and I will simplify or find the derivative of x right now to save time later. Dx is equal to secant squared t. That is because the derivative of tangent t is secant squared t dt. I'm sorry for that. So there's something quite interesting about 1 over x squared plus 4x plus 5. Surprisingly, we know a method called completing the square, which means that you want to create one particular quadratic equation and make it a square of the same factor. The factor that we hope to square in order to complete the square is x plus 2, but you see we have a lone 5 here, which is unfortunately not a 4. However, we can do this by we can complete the square by taking out a 1 figuratively from the 5 and changing it to 1 over x squared plus 4x plus 4 plus 1. As you see here, we can now actually complete the square. dx, I apologize for that. The integral of 1 over x plus 2 squared plus 1 dx is what it now equals right now. As you see, we can substitute x is equal to tangent t minus 2. That means, using red, x plus 2 is equal to tangent t. And we can plug in that for x plus 2 here in the completion of the square, back to gold. This is now equal to the integral of 1 over tangent squared t plus 1 dx. You have to be careful here because right now we still have a dx while we still really need a dt. That means we can substitute in whatever is written here in for dx. Continuing onward, that is the integral of 1 over tangent squared t plus 1 times secant squared t dt. Because of one particular trigonometric identity we know that 1 plus tangent squared t is equal to secant squared t. That means that this entire integral becomes the integral of 1 over secant squared t times secant squared t dt. And we are left with the integral of d1 dt. This means that the integral of 1 dt is equal to t plus c for some random constant c. Unfortunately, we want to find the substitution in x, not t. So, as you see here, we should copy down what our regular substitution for x was. X equals tangent t minus 2 and solve for t. X plus 2 is equal to tangent t. T is equal to arc tangent x plus 2. And so the integral of 1 over x squared plus 4x plus 5 is equal to arctan of x plus 2 plus dx plus c.